In this lesson, you will learn how to use the math class methods related to trigonometry, specifically sine, cosine, tangent, square root, and 2 radians. The study of trigonometry is an advanced branch of mathematics dealing with right triangles, specifically the useful properties of their 2 other angles and related side lengths. A right triangle always has one right angle and then 2 acute angles. A commonly used Greek alphabet letter used to designate either of these 2 other angles is theta, as you can see in this diagram. Angle theta can be either of these 2 acute angles and always has 3 related sides from its point of view: the adjacent side, x in the diagram, the opposite side, y, and the diagonal side, r, also known as the hypotenuse. Note, the letters used to represent the 3 sides of a right triangle can be any letters, not always r, x, and y. Depending on the measure of angle theta, the lengths of the 3 related sides can be predicted very accurately using 3 different ratios: sine, cosine, and tangent. These 3 ratios are the fundamental building blocks of trigonometry and need to be memorized and well understood. The sine ratio always involves the 2 sides, opposite and hypotenuse, and can easily be memorized by the acronym SO, which designates the equation sine equals opposite over hypotenuse. The cosine ratio always involves the 2 sides adjacent and hypotenuse, and can easily be memorized by the acronym CA, which designates the equation cosine equals adjacent over hypotenuse. The tangent ratio always involves the 2 sides opposite and adjacent, and can easily be memorized by the acronym TOA, which designates the equation tangent equals opposite over adjacent. The combined acronym using all 3 is SO, CA, TOA, which also can easily be memorized. Here is a Java program and equivalent spreadsheet showing the real number values of several common angles. In both the spreadsheet and Java program, degree angle measures must be converted to radians, since both require radian measures for angles. Notice carefully the 90-degree angle cosine and tangent values in the Java program output. The cosine value is a very, very small number, as close as possible to 0, indicating 0. And the tangent is a very, very large value, essentially representing an undefined number, which it is. So, how are these 3 ratios used? Shown here are 2 special right triangles: the 45-45-90, often called the isosceles right triangle, and the 30-60-90, a good place to begin this discussion. Let's begin with a 45-45-90 triangle. What do you notice? Since the 2 acute angles have the same measure, 45 degrees each, it is logical to assume what else? Of course, the 2 shorter sides are also the same length. Why is this so important? Let's think of a real-world example. Say you find a tall structure, tree, or pole, and want to know how tall it is. How can you use the 45-45-90 triangle to do this? Simple. Find a location on level ground at a distance far enough away from the tree so that the angle formed looking at the top of the tree from the ground to its base is 45 degrees. Measure the distance from that spot to the base of the tree, and you have the height of the tree as well. If the distance is 50 feet along the ground, this means the tree is 50 feet tall. To represent this in a formal trig equation is to use the tangent ratio, the one using the 2 shorter sides, the opposite over the adjacent, like this. Tangent of 45 is equal to x divided by 50, opposite over adjacent. Then solve for x by multiplying both sides of the equation by 50. 50 times tangent 45. The value for the tangent of a 45-degree angle is always 1, which results in 50 times 1, which is the value of x. The height of the tree is 50, which we figured out before, but now you know how to do it using the equation. Here is the Java program to solve this problem. A variable called ground is given the value 50, and then we output the calculation ground times the tangent of the radian's value of the measure 45-degree angle. Since this is the special right triangle 45, 45, 90, and since we know the two shorter sides are always equal in length, the shortcut calculation is just to use the ground length measure as the height also, since both are of length x in this special case, as we did in the opening example. In this same situation, what if you wanted to know how long a cable would stretch from the spot on the ground to the top of the tree? How could that be calculated using Trig? Again, a fairly simple solution. Since we know the length of the adjacent side of the triangle, length along the ground, and need to know the hypotenuse, the appropriate ratio to use is the cosine, ka, and the proper trig equation is cosine of 45 degrees is equal to 50 divided by h. We convert the equation cosine 45 equals 50 over h to ratio format. Cosine 45 over 1 is equal to 50 over h. Cross multiply to get cosine of 45 times h is equal to 50, and then divide both sides by cosine of 45, which is approximately 0.707, with a result of approximately 70.7, as you can see in the two calculator images shown here. The cable length from the spot on the ground to the top of the tree would be almost 71 feet. Here is the Java program to solve this problem. A quicker and easier way to solve this is to use the other well-known fact about 45, 45, 90 triangles, where the hypotenuse length is always the side length times the square root of 2, which is about 1.414. And this comes out to be the same value. Here is the Java program to solve this problem. Another special right triangle with very useful characteristics is the 30, 60, 90 triangle, as shown here. The same find the height problem can be solved here, again using tangent, assuming the ground distance is again 50, but on a different tree. This time the angle used is 30 degrees, and the ratio used is tangent, since the opposite and adjacent sides again are used. The equation is tangent 30 is equal to x divided by 50. And again, the solution is to multiply both sides by 50. 50 times tangent 30, with the solution of x is equal to 28.8. And again, you see the calculator images to prove this. Here is the Java program to solve this problem. A cool fact about 30, 60, 90 triangles is if you know the shortest side x, you can just double it to find the longest side, 2x, the hypotenuse, and multiply the short side by the square root of 3 to get the middle side. So, if the height of the tree is 28.8, a cable from the spot on the ground to the top of the tree would be double that value, almost 58. Here is the Java program to solve this problem. If you know the ground measure to the tree is 50, just divide 50 by the square root of 3 to get the height of the tree, with the same result as we got before. Finally, if the right triangle you can achieve is neither of these two special right triangles, say with a ground angle of 55 degrees trying to measure the height of a tall building 57 feet away, you can still use the appropriate ratio, tangent again in this case, and solve the equation. Tangent of 55 is equal to height divided by 57. Solve by multiplying both sides by 57. Height is equal to 81.4. Here is the Java program to solve that problem. We changed the value of ground to 57 this time, but we use the same basic formula, ground times the tangent of the radians version of 55 degrees. And you can see the answer is the same.